Hi, my dear student. Yes, in our previous class, we have discussed very important concept of the inverse trigonometric function. In the inverse trigonometric function, we have discussed sine inverse x, cos inverse x, cosec inverse x. Now, another most important concept for the sec inverse of x. You know that, what do you mean by cos inverse of x? So, R implies minus 1 to 1. When you can take cos inverse minus 1 to 1 implies 0 to pi by close interval. Right? On this base, now we are going to discuss about sec x is equal to 1 by cos x. So, in this case, the domain of the function, it means set I can consider the flower R minus flower bracket x such that x is equal to 2n plus 1 pi by 2 n belongs to z complete flower bracket, and range of the function R minus of minus 1 to 1 open bracket. So this condition, what we are going to say that the function, it cannot exist or the cannot talk with the, or it cannot find out, it cannot, it means we are not saying for the 1 1 and onto function and bisective. When this one case, we are not going to take or not take 1 1 and onto, obviously it does not exist for the inverse. So by the conditions of this one, minus 1 y minus 1 less than y less than 1, this is the class interval, restricted is there. So next time we are going to find out all these things, when we are going to take some restriction about the sec inverse x, sec x. In this case, particularly we are going to define for the values of restrictions whenever we can take the point x is there. That means some conditions 0 to pi minus, it means minus pi by 2. So before that restriction, we not define odd multiplicative of pi by 2, right? Keep in our mind. So that expression should be go to 0, integral multiple. That is also very clearly expressed. And that later we are going to express for the some conditions. Already you know that the restrictions are there point. Some in this sec x, we are conditions put in for the some class intervals. They are going to accept that point. Analysis, all these points are there in this case. Let us discuss one by one how to take the values. Now I am going to defining sec x 1 by cos x, right? The domain of y is equal to sec x. The set of R except this point x such that x is equal to 2n plus 1 pi by 2 n belongs to z. And the range is clearly says that R hyphen minus 1 to 1. It means what? The second means the line which passing through the circle, right? Assume all real except the point. Already I said to you, minus 1 less than y less than 1 and not depend for the odd multiplicative pi by 2. Odd multiplicative pi by 2. Keep in our mind, this is a very clear and static point. So when we are going to up to here, we are going to discuss, it is not exist for 1 1 and onto, but here they exist. If you restrict the domain of second function, so when you can take second, it means we are going to passing through the point 0 to pi minus pi by 2. So look at this one, 0 to pi close interval pi by 2. This one, it means exists for 1 1 and onto with its range set R hyphen minus 1 to 1. Actually, the second functions are restricted. There are so many class intervals, right? So minus pi 0, minus pi by 2, 0 pi, pi by 2, pi, 2 pi, 3 pi by 2, bisective. When you can take bisective, it is 1 1 and onto, right? So 1 1 and onto exist, then it is called the, we are going to express for the 0 to pi minus pi by 2. This is called the principal value of a branches, most important concept. So this one we are going to denote it for the graph, right? How to take the graph? So you know that 0, pi by 2, pi, 2 pi. So before 2 pi, 3 pi by 2. So 2 pi, simple values, right? So you can express for the values. In this case, we are going to take cos theta. Cos 0 is 1. Pi by 2, 0. Minus 1. So here 0. Here plus 1. So when you can take sec x or sec theta, right? So here 1 reciprocal, infinity, minus 1. Here 0, it means infinity. Here plus 1. The odd multiplicative, look at this one, pi by 2, 3 pi by 2, odd multiplicative. So by the cases of this one, we know that here that, so cos theta, it means cos 0, 1. So cos pi by 2, got it to 0. Sine, sorry, here not going to pi, minus 1. Cos 3 pi by 2, it means got it to 0. So complete work, we are going to express that graph. This is a y is equal to sec x, right? In this graph, so here that point 0. So here y, here y dash. So shall I take minus 1, here plus 1. So pi by 2, minus pi by 2, pi by 2, pi. Here 3 pi by 2, here 2 pi, right? Similar manner, minus pi, minus 3 pi by 2. So here minus 2 pi x dash. So here x. So observe sec 0 is 1. Sec 0 is 1. Pi by 2, that infinity goes on. I can take here pi by 2. Pi by 2, here also pi by 2, right? So this point should be taken, right? Observe that graph. So here infinity minus it's also infinity. So here pi is there, minus 1, right? I can take here minus 1. So already you know that pi by 2 infinity, that point. So pi, it means 1, clear, and 3 pi by 2 is also infinity, that pictures have given. So here also pi is you can take in the form of positive, right? Observe here goes on the point. So here infinity, here. So like that you can take here also. This is the graph to represent. ಅಲ್ಲಿ ಬೇರೆ ಬಂದಿತ್ತು, ಇದನ್ನೇ ಈ ಫಾರ್ಮನ್ನು ನೀವು ಡಿಫೈನ್ ಮಾಡ್ಕೊಂಬಿಡಿ. y is equal to, shall I write y is equal to, so or otherwise sec inverse of x is equal to y in this formation, right? So here the point minus 1 x dash, here plus 1 x y dash. So here pi by 2, 0, here pi, here 3 pi by 2, here 2 pi. So where the point infinity, here look at this one, shall I take a graph, here also minus pi by 2. So here that point, so here pi, right, here minus, here minus, here minus 3 pi by 2, here 2 pi. Right, this graph will be, sorry, not for here, that point, right? This is the point minus 2 pi, that point. So here that point, so here that point, here that point, right? So sec 0 is 0, no problem. Sec 0 is 1, sec 0 is 1, right? Here sec pi by 2 infinity, sec pi by 2 infinity goes on up to here, this one, right? Like that in the form of pi by 2. So here also you can take in that form, right, the graph. So 0, here you can take in the negative formation. So you can express for the negative, right? So up to plus 1 will be there, then only I can take the range, Alright, this is the graph of sec inverse and this is the y is equal to sec x and the point. So this is the most important. We have solved 4 examples. These are the most important. Sin x, cos x, cosec x, sec x. Next class, tan x and cot x. I will go to discuss in that one, or otherwise I will given a table. You can practice. Thank you so much. I'll continue the next one.